All right, let's rock in part two. So this is the next page. The first page is all this review about all the vocabulary, which is really important. So at some point you might want to move those into Cornell notes so you can use them. Because again, remember Cornell formatted only. And I'm going to be a whole lot more jerkish this time around about what notes you can use. So please be aware of that. So here we're just doing some identifying. So here's where you really have to review and kind of understand what the rules look like, what the structures look like. And then down here you got some logic stuff, which is really, really important. So pay really close attention to this part especially. But anyway, let's just go ahead and bust through it. So if I'm looking here, the key is I'm looking at an algebraic rule, and I'm looking at addition or subtraction. So like this is big. If I'm looking at addition and subtraction, that means I have to be looking at a translation. Because this is going to make me shift like 4 units to the right, and then 10 units down. So that's the same exact thing as employing a vector, i.e. a translation, okay? So translation is the answer. Here we go. Looks like we have xy going to 4x and then just regular y. This seems like a trick question. Not that I ever put a trick question in any kind of test or anything, but kind of check this out. Let's say I have this point. I'm actually going to use a square, and I'm going to blow it up by 4x y. So what this basically means is that the x is going to get 4 times as long, but the y is going to stay the same length. So this is going to be 4 times wider than it is tall, but the height should stay the same. So my new object will look like this, basically. Okay, so this is my old object. This is my new object. Okay, that's definitely not a rotation, translation, or reflection, but it's also not a dilation either. So this is actually nothing. Because if it was a dilation, you'd actually need the same number to multiply it to be a dilation. Same number. And it can't be anything else because, again, translations are just going to be addition. Rotation and reflections use the same numbers, just kind of flipped around. Let's look at this one. Here's what I'm talking about. All right. So this could actually be a couple things. I'm actually going to claim this is a reflection or rotation because we really actually can't tell here. If you look at a coordinate plane here, and I have this point, let's call this guy right here called A. If I use this as a rule, this could be now A prime. So two things can actually occur. Well, first of all, I could look at this as a reflection over the axis. But alternatively, I could also just pick a point like this guy, and I could call this a rotation. Okay, so for this one, especially just for a single point, it's really hard to tell. Now, the good news is they're both rigid, so you could actually pick either one for this particular one. Now, for a whole shape, it becomes more clear, but just for a point, that's a no-go. Okay, let's move on to part 4. Okay, check this out. That is a point, and that is an angle. So if I'm given a point and an angle, that's got to be a rotation, just a rotation. If it was a reflection, that'd be like a line segment. If it was just going to be a translation, they wouldn't have given me an angle because it moves on a vector. Ooh, look at this guy. So this one actually is a vector. These little marks here indicate vector notation. So that indicates a vector, which means this is a translation. Okay, so like the way to interpret this would be x minus 3 and then y minus 2. That is a vector. That's algebraic form. That's definitely going to be a translation. So this is just a line. So this is going to be my line of reflection. So this is going to be definitely a reflection. So you can certainly see just by examining the information what you have, and that's an important part of this, being able to sight recognize that. So that is that part of it. Let's move on to this guy. So here we want to talk about the structure. And so again, it's definitely going back to your notes, memorizing this. But that is a perpendicular bisector. Which makes this a reflection. Okay, these are vectors, which makes this a translation. Here we have a center, and we have angles. Okay, so if I have a center and I have an angle, that's going to be a rotation. Here I have a center, and I have these getting bigger. Looks like by the same ratio, and I definitely have lines of dilation. So this will be a dilation. It's also the only non-rigid transformation here, so that should be pretty easy to pick out. All right. Here's where it gets a little tricky, but not honestly too tricky. I mean, we can definitely kind of see what's going on if we pay close attention. So I'm going to draw it out for, well, first I'm going to claim what it is, and then I'll show you what I mean. I believe this is a rotation, and just a rotation. Here's the reason why. If I draw this guy out, so I can pull it and turn it, I notice that even though it's been turned, here the white is kind of to the right of the purple, and so is this here. So the white is actually to the right of the purple. So if I were to cut this out and move it, and you can kind of do this in your mind, there is no reflection here. Like, it's definitely not just a translation, because the translation would be oriented the same way. This has definitely been turned, and it's been turned in a way that I don't have to flip it, because again, if I know it's kind of a weird way to look at it, but the white is to the right up to the purple here, and it's to the right of the purple there. So that means no reflection, just a rotation, because a reflection would actually change that order. Here we can do the same thing. Now here, using the same analysis as I did before, this has definitely been reflected. Maybe rotated also, but at least reflected. And here's the reason why. Okay, so the white is to the right, okay, here, but here it's white is to the left. Which means it had to be at least reflected. Okay, it could have been rotated also, and I'll put like maybe plus rotation. But the big thing is that you have to recognize the reflection here. Here, same idea. White is to the right. And here, to the left of purple. Okay, so this is definitely again being reflected. With maybe just a little rotation thrown in. Okay. So that's going to resume. I'm going to go and stop here, and we'll do the next part. So this will be part 2. So again, the sight recognition is important, whether you have it by the rule or the structure or just logically. You have to understand like how these translations or transformations, I should say, affect your object. The big thing being that reflection is the only thing that could change the order of stuff, like we talked about that in class. So that's going to be the tricky part here. So please be aware of that. All right. So that's the end of part 2. You'll be getting part 3 in a second.